Welcome back everyone. In today's session we are going to continue the application of distance formula which we learned in our previous session. So just to recall, I am again explaining you how to apply distance formula. Imagine there are 2 points given. Okay, the points you must take them as x1 y1 x2 y2 and we'll apply this distance formula, that is under root x2 minus x1 whole square plus y2 minus y1 whole square. The points will be given as 0 comma 0 x1 y1 and the other point will be 6 comma 8. These are the points. Okay, so this will be our x1 y1, xy they will not be x1 x2. Okay, few students will get confused. So x1 y1, these are the coordinates on the coordinate system. How will be the coordinates? X comma y. Yeah, so as there are two coordinates, we are numbering them as labeling them as x1 y1 and the other I'll label as x2 y2. If I have one more coordinate, then I'll name it as x3 y3. Okay, but here we don't have it. So we apply this formula, x2 minus x1 whole square, that is 6 minus 0 whole square, and y2 minus y1 whole square, that is this 8 minus 0 whole square. Very simple. So we get the answer 36 plus 64, that is root 100, and the distance between the points is 10 units. Okay, so this was the concept of the last session. Now let's see some more questions from exercise 1. So this is the first question of exercise 7.1. Third bit, the first and second bits you can try, those are same like previous what we have done. These are variables type. Okay, so the 2 points are given as a comma b and minus a comma minus b. These 2 points are on the graph, so we need to find distance between the points. So what is our x1 y1 here? X1 is a and y1 is b. Yeah, this is our x1 y1. Then x2, what is x2? X2 is minus a and y2 is minus b. We'll substitute these in the formula. The formula is x2 minus x1, so x2 minus x1 or x1 minus x2, that doesn't matter. So a minus of minus a whole square, then plus y2 minus y1 or y1 minus y2. I already said you that. So y1 minus y2, b minus of minus b whole square. Okay, so a plus a is 2a whole square and b plus b is 2b whole square. 2a whole square is 4a square plus 4b square, and 4 taken common here, 4 comes out and 4 becomes 2. Square root of 4 is 2. If you have a perfect square root, then find it. So square root of 4 is 2 and 2 came out of the root. So final answer of this is 2 under root a square plus b square. So this is the way we find distance. We can find distance between any 2 points on the graph. Now let's jump to the next concept. You can clearly see the difference between collinear points and non-collinear points here. So collinear points, how will you define collinear points? Points lying on the same line. Okay, you can clearly see a, b, c, the points are lying on the same line, so they are called collinear points. And d, e and f, you can see they are not on the same line. If you join them, you will not get a single line. Yeah, so they are non-collinear points. So we are going to learn the concept of collinear points or non-collinear points in our next question. So what are collinear points? Points lying on the same line, which lie on the same line, lying on the same line. You can take this definition in your class books and draw the figures. And points which do not lie on the same line are called non-collinear points. So next question is about this only. So here he is asking you determine if the points are collinear without drawing the graph. You don't have to draw the graph. If this comes in 1 mark, you can roughly draw a graph and say that they are collinear. Okay, that doesn't matter. But if this comes in 3 marks or 4 marks, then you need to solve it by using formula and prove that they are collinear or they are not. So 3 points are given to you, 1 comma 5, 2 comma 3 and minus 2 comma minus 11. We have to check whether they are collinear or not. So for that collinearity, you remember this figure, the first one. Okay, this figure I am going to use now. So let the 3 points be A, B, C. Collinear points are points which fall on the same line. So there are 3 possible cases. Okay, to prove that these are collinear, there are 3 possible ways. First way, the points can be like this, A, B, C. So when A, B, C are arranged in this way, so I can say AB plus BC is equal to AC or not. Yes, if I add AB and BC, I get AC. So that is distance AB and the distance BC. The sum of these two should be equal to the distance AC. Then we can say that they are collinear. If not this, okay, if this is not satisfied, then the points can be like this. Yeah, I can arrange them in this order also, B, A, C. Okay, because order is not mentioned here. These are 3 points on a line, that's all. So we have to check on the graph, we have to check whether they lie on a line or not. So BAC, if I write in this way, BA plus AC is equal to BC or not. BA plus AC is equal to BC. So we are going to check which condition these points satisfy, the first one or the second one. Is there any other possible way of arranging these points other than first and second? Yes, there is another way. I can arrange this way also, BCA. Okay, so BCA, in this case BC plus CA gives you BA. The sum of BC and CA gives you BA. So these are the 3 possible cases. So we are going to check whether these points satisfy any one of these cases. If it satisfies, then we say they are collinear. If it doesn't, then the points are not collinear. So we'll find the distance AB, BC and CA. You see, in all of these distance, we have to find distance AB, we have to find BC and we have to find CA. These 3 distances we will find. How do we find distance now? We'll apply distance formula, okay, which we have learned. So let's apply distance formula for each one of these and find distances. Finding the distance AB first, so x1, y1 1 comma 5 and x2, y2 is 2 and 3. So we'll find we found the distance and the distance is root 5. Then we'll find BC. So what is BC? This is B and C. x1, y1 is 2 and 3 and x2 and y2 is -2, -11. So we'll find the distance BC by using distance formula here again. So I am getting 212 units. Okay, hope you are perfect in finding distance. You don't need further explanation of finding distance. Okay, so whichever distance you are finding, you take those respective points. Okay, you are finding distance AB, so you take 1 comma 5 and 2 comma 3. This is your A and B. Then take x1, y1, x2, y2. Then if you are finding BC, just remember what is B and C. The B coordinates of B are 2 comma 3 and this is -2, -11. So this is your x1 y1, this is your x2 y2. Okay, I am briefly explaining you because this is a new concept. So 212, then what's left over? AB, BC, CA. Okay, CA. So this 212 can also be splitted as 253 units. Then CA, x1. What is our C and A? C is -2 -11 and A is 1 comma 5. So -2 -11 and 1 comma 5. So this is your x1 y1 here. Doesn't matter, x1 y1 x2 y2 can be interchanged, means I can find AC or CA, both the distance will be equal. Anyway you find the distance, okay, whether you go from A to C or you go from C to A, distance remains the same. x1 y1, so 1 comma 5, and x2 y2 is -2 -11. Again we found the distance using the formula, so we got 265 under root 265 units. So these are the three distances we have got. Okay, now we'll check the cases. So what was the distance AB? Root 5. Distance BC was 2 root 53. AC is 2 root 265. So we'll check with the first case. The first case which we discussed, that is AB plus BC is equal to AC. So is distance AB root 5 and BC is 2 root 53, is it equal to this? No. No way it will be equal. Then go to the next case, BA plus AC, that is root 5 plus 2 root 65, root 265. Is it equal to 2 root 53? No, not at all. So these two cases are not satisfied. Let's go for the third, BC plus CA. BC, CA is not equal to root 5 again, so this is also not equal. Hence case 3 is also not true. Since all three cases are not satisfied, the points are not collinear. If any one of the case satisfies, suppose if you get equal in any one of the case, then you can say that the points are collinear. Like if you are adding 3 plus 5, what you must have here? You must have 8. That is, if AB is 3 and BC is this, CA must be 8. Then 3 plus 5 is equals to 8. Then we can say that the points are collinear. Okay, collinearity of points could be checked by using area of triangle formula 2. Okay, we can even check whether the points are collinear or not by using the concept of area of triangle, which is deleted from your syllabus. So this is the only method which you can use in the exams for solving collinearity. I'll give you some questions based on this concept. You'll be solving those questions to get perfect. Take care.